Okay, so hello everyone. For our today's topic, we have continuity. That's why our lesson objectives for today are the following. We have to illustrate continuity of a function at a number, determine whether a function is continuous at a number or not, determine whether a function is continuous on an interval or not, and illustrate different types of discontinuity, namely whole or removable, jump or essential discontinuity, asymptotic or infinite discontinuity. Okay, so we have the word continuity, no? So we know what continuous means in the real sense of the word in Tagalog or in Filipino, tuloy-tuloy. A function is said to be continuous at x equals a if there is no interruption in the graph of f of x at a, meaning its graph is unbroken at a and there is no hole, jump, or gap. Okay, so when we say continuity of a function at a point, a function is said to be continuous at a point, say x equals a. This is our test value. If the following three conditions are satisfied. So first, f of a is defined. That means f of a is a real number. Okay? Okay lang siya mag-zero, mag-negative. Wag lang maging undefined or indeterminate. And then secondly, limit of f of x as x approaches a exists. Okay. And then lastly, the limit of the function f of x as x approaches a, the answer in number 2, must be equal to the answer in number 1, which is the f of a. So we have the functional value being equal to the limit value. For example, let's discuss the continuity of f of x equal to 5 plus 2x minus x cubed at x equals 1. So 1 is our a. This is our test value, no? So ito yung a natin. So we have f of 1. Okay, so first condition, substitution. So 5 plus 2 minus 1, that would be 7 minus 1 or 6, no? And then second, so check tayo sa number 1. So number 2, limit of f of x as x approaches 1. So we get the limit of this as x approaches 1 again by substituting 1 to our x variable, we will get 6. So condition 2 is satisfied. Check na naman. And if we compare our answers here, yan, we'll see that the limit of f of x as x approaches 1 is equal to f of 1. So they are just equal. So meaning condition 3 is also satisfied. Yay! Therefore, f of x is continuous at x equals 1. Okay, since all three conditions are satisfied. And fun fact, all polynomials are continuous. This is a cubic function. So it must be a continuous function. So wala yung point of discontinuity. We can graph this as tuloy-tuloy. Yan. Okay, let's go to removable discontinuity. So when we say a function is or a function is said to have removable discontinuity at x equals a if limit of f of x exists as x approaches a but is not equal to the functional value f of a. Nag-i-exist yung limit pero hindi equal dun sa functional value natin. Okay? So pwedeng ganito yung itsura niya. Ito yung limit mo, no? Nagiging equal sa certain value, say L. Let's consider this. Kasi, di ba, as x approaches, say A, let's shift to open. Okay. Say this is the x equals A. Tapos ito yung L. So as x approaches A, di ba pag ganun yung kanyang behavior? Ito, looking at this behavior pag ganun. It approaches this hole. So yung corresponding y coordinate associated with this hole is L. So same behavior of the graph here. Kung nag-x approaches A tayo from the right, it's towards this, no? Towards this hole again, where the associated y value is L. Pero pag kinuha natin yung function value, yan, at x equals A, we have this solid point kasi mga functional value cannot be a whole. So, dapat mga solid point siya. So, this is the associated f of A. Yan. Ito yung na-associate natin with this solid point over here. Okay. So, as you can see, these are not equal. Si f of A is not equal to L because of, as stated here. That's why this is a removable discontinuity. Nag-i-exist yung limit, diba? The limit from the left is equal to the limit from the right, and both are equal to a real number L. Pero yung first condition, yung third condition rather, was not met. Okay? Whereas yung jump discontinuity, paano naman yon? A function is said to have jump discontinuity at x equals a if the limit as x approaches a from the left is not equal to the limit as x approaches a from the right. So, ito not equal. So, yung condition 2, hindi niya na nasatisfy. So, that's why it's a jump discontinuity. So, ito yung illustration natin. As x approaches a, say this is the a value. As x approaches a from the left, ito yung behavior ng graph natin. So, it's leading towards this hole. Yan. So, ito yung value na nakukuha niya. Say this is L sub 1. Okay? Pero as x approaches a from the right, ito yung behavior ng function. Okay? So, it's leading towards this hole naman. So, let's call the associated y of this L sub 2. As you can see, the L1 is not equal to L2. O yan. So, the limit of f of x as x approaches a from the left is not equal to the limit of f of x as x approaches a from the right. So, jump discontinuity. Parang lumundag, di ba, from this to that point. Okay, now, what about infinite discontinuity? As the term suggests, no, may infinity na concern. So, a function is said to have infinite discontinuity at this x equals a if limit as x approaches a from the left or di kaya yung limit as x approaches a from the right is equal to positive or negative infinity. Just like in here, if we consider the point or the a equal to -1, kunwari ito yung a natin, as we have x approaching -1 from the left, the graph has this behavior. Trace natin, no? Ito yung behavior niya. Okay? So, this will continue to go up, 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 up. So, magiging towards positive infinity yan kung from the left, no? Ganon din yung from the right niya, no? This is just an example, by the way. So, ito naman yung itatrace nating behavior as x approaches -1 from the right. So, up, 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 up. Yan. So, it will continue to go up, no? Kaya, both from the left and from the right, equally nga yung limit. Kaya lang, this is not a real number. This is just a behavior of the function. So, it's equal to positive infinity. Okay, so this is an infinite discontinuity. Kasi di din naman natin mag-graph ng tuloy-tuloy yung function. Meron tayong gap dun sa x equals -1. And moreover, the line x equals -1 here is a vertical asymptote. So if we encounter this infinite discontinuity, na-satisfy niya yun, that means this line, nagiging line equation na to, the line x equals a is actually a vertical asymptote. Okay, so ito ulit yung ating condition. Kapag all three conditions are satisfied, that means we have a continuous function. Kapag condition 1, satisfied, condition 2, nag-fail, ibig sabihin meron tayong jump or infinite discontinuity, either of the two. No? So, in those cases, pareho tayong merong essential discontinuity or irremovable discontinuity. Okay? Pero kapag yung condition 1, hindi niya na-satisfy, condition 2, okay siya, ibig sabihin, meron tayong removable discontinuity and we have to redefine our function. Okay. Pag condition 1, okay. Condition 2, okay. Pero pagdating sa condition 3, hindi nag-equal yung dalawa, yung function value at limit value, nag-fail yung condition 3, removable pa rin yung discontinuity. Kasi importante kay removable discontinuity is yung condition 2. Yan. So, that means i-redefine pa rin natin yung ating function. Okay. You can always pause the video if you still want to absorb or digest what I've been saying. So, let's determine the points of discontinuity and then classify the discontinuity. So, for this example, we have this point at x equals 1. And then, we have a jump discontinuity there kasi parang, di ba, lumundag from this point to that hole. Okay, so as you can see, the limit as x approaches 1 from the left, ito yung behavior ng graph. So it's leading towards that solid point. So ang limit as x approaches 1 from the left is positive 1. Associated y with the solid point is 1. Pero as x approaches y from the right, as x approaches 1 from the right, ito yung ating behavior. Ayan, 1 from the right. And the associated y with this hole, it's leading towards that hole eh. Associated y will be 3. Okay, so magkaiba. Condition 2 is not satisfied. Other point of discontinuity, meron pa bang nakikita? This one, ang at x equals 2. Okay, so at x equals 2, from the left, ito yung behavior niya. As x approaches as x approaches 2 from the left, pag gano'n, no? Siyempre, papunta dun sa solid point na to. The limit is 3. Pero kapag from the right of 2, ayan, ito yung behavior. It's leading towards that hollow point. The limit is 2. Ayan. So again, that will be a jump discontinuity also. Okay. Now let's move on to this example. Determine pa rin the points of discontinuity. So we have this point, no, where the associated x there is 1. Okay, so x at x equals 1, what kind of discontinuity do we have? That will be, yan, parang pwedeng sabihin jump discontinuity, parang lumundag from this hole to that solid point. Pero makikita natin the limit from both sides are equal kasi from the left of 1, it's this, no? The graph has this behavior leading towards that hollow point. And from the right of 1, papunta tayo sa hollow point pa rin na yun, where the associated y value is 4. So this is the limit from both sides. Okay? Pero yung functional value natin, the f of 1 is equal to 2. Yan. So yung condition 3, yung hindi niya na-satisfy, that's why this is removable discontinuity. Okay, what about this example? Ano yung mga types of, ano yung points muna natin of discontinuity? We have this, ang associated x natin dyan ay negative 1. Okay, so at x equals negative 1, ayun. Ito yung behavior ng graph, pagka papuntang negative 1 from the left, it's leading towards that solid point. Pero kapag from the right, it's leading towards that hollow point. Okay, so magkaiba yung limit from both sides. Okay, so jump discontinuity. Ano pa yung isa? This x here where x equals 3. So again, yung behavior niya, pag sa left, papunta sa solid point na yon. Pag sa right, papunta naman dun sa hollow point. So magkaiba na naman yung limit from either side. So jump discontinuity also. Okay, now let's go to this example. What kind of, ano muna pala yung ating point of discontinuity na nakikita natin? We have at x equals negative 4. So at x equals negative 4, as you can see, halos tuloy-tuloy na sana, no? Yung magpag-graph natin, nilagyan lang ng buta. So meaning, pag galing tayo sa left ni negative 4, ito yung behavior ng function. So papunta dun sa hole na yon. Pero pag galing tayo sa right, pag ganun yung behavior, papunta pa rin doon sa same hole or same point, same hollow point. So ibig sabihin, parehas lang yung limit from either side. That's why this is removable discontinuity. Pero pagdating doon sa isang point of discontinuity, which is x equals 2, or negative 2 rather, kanina negative 4, ano? Ngayon negative 2 naman, makikita natin na papunta siya sa negative infinity kapag ka nanggagaling tayo sa left side ni negative 2. So we have limit from the left of negative 2 approaching positive or negative infinity. So it's actually a vertical asymptote. That's why at x equals negative 2, we have infinite discontinuity. Okay. Now, let's move on to this one. No? This time, we're not given with the graph, but with the piecewise function. Let's determine the possible points of discontinuity muna. So, meron tayong possible points of discontinuity dun sa nakikita nating may tendency maging undefined or indeterminate yung function. O di ka may tendency hindi mag-exist yung limit. Kasi di ba yun yung pagsususpetsahan mo, yung hindi masatisfy yung tatlong conditions. Okay? So in the case of this one, hindi ito magiging undefined kasi this one is, these two are linear functions. So 2x saka 3 minus x. Never yan magiging undefined. Pero, because of this transition point or parang, ano, di ba, we have a piecewise function and this is a transition point or critical point. Yan. Lalabas, this one automatically becomes our possible point of discontinuity. Kasi posibleng sa left tsaka sa right side ni 0, hindi pareho yung limit. Okay? Kasi kukunin mo yung limit from both sides of 0 eh. So, siya yung pagsususpetsahan natin din na possible point of discontinuity. So, automatically, no, yung nakikita nating transition point or points sa isang piecewise function becomes a possible point of discontinuity. In this case, isa lang, no, si 0. Okay? So, ito yung A natin. This is our test value. This is our A. Okay? So, balikan yung ating definition ng mga continuity, yung conditions. Condition 1, dapat nag-exist daw yung function. Function value, so we get G of 0. G of 0, so nasan yung equality at 0? Dito. So, we'll be making use of this function. Function definition, 3 minus 0, that will be 3. So that will be a check. Condition number 2, kunin natin yung limit of g of x as x approaches 0. So since transition point nga siya, we need to get the limit from the left tsaka from the right. So medyo na-spoil na, no? Bakit nga ba x yun? Teka nga. As x approaches 0 from the left of g of x, okay, tsaka yung limit as x approaches 0 from the right of g of x. Okay, so from the left, no, parang ito yung ating 0. Sa left, ang definition ay 2x coming from here. Tapos sa right, we have 3 minus x. Okay, so we will be replacing g of x by 2x kasi kung nasa left side tayo ng 0. So replacing that g of x by 2x. Tapos dito naman, we have limit x approaches 0 from the right. G of x will be defined as 3 minus x. So we'll be replacing our g of x here by 3 minus x. Kasi ito yung ating graph. So binomial, kaya lagyan natin ng parentheses. Okay, so dito muna tayo sa isang side. As x approaches 0 from the left, this will approach 2 times 0. So 0. Okay. Dito naman, as x approaches 0, this will approach 3 minus 0 or 3. So as you can see, these are not equal. Okay, that's why we have an x here. So meron na tayong conclusion, hindi na tayo magpo-proceed sa third condition kasi may hindi na nasatisfy. We have a jump discontinuity at x equals 0. Okay. Now, let's proceed to our next example. Let's have this one. Sabi natin, yung mga PPDs natin, automatically, nakikita natin points dito. Si negative 2, tsaka si positive 2. Okay, let's see, no? Tingnan muna natin yung by the way, check natin, no? This will never be undefined. Okay, so wala na. Aside from negative 2 and 2, wala na tayong ibang possible points of discontinuity. Okay, sila lang yung pagsususpetsahan natin na pwedeng discontinuous yung function. Unahin natin yung at x equals negative 2. First condition, f of negative 2. Saan ba yung f of negative 2? Nandito yung equality. So we have 3 minus negative 2 squared is 4. So 3 minus 4 will be negative 1. So we have a check there. Okay. Now we go to the limit. Kunin natin yung limit as x approaches negative 2. Kunin natin yung from the left tsaka from the right. No? So from the left, bakit negative 1 yun? Tingnan natin ha. So we have limit as x approaches negative 2 from the left. Okay, so from the left, ito yung gagamitin natin, si negative 1. Yan. Diretso ko na, no? Palitan ko na si f of x ng negative 1. Okay. So limit of a constant is just equal to that constant negative 1. Okay. Tapos yung isa naman, yung limit from the right of negative 2. Ayan. So sa right ni negative 2, di ba? Ito yun. Negative 2, positive 2. Dito negative 1 yung definition ng function. Pero sa gitnang interval, we have 3 minus x squared. Yan. So we'll be making use of the 3 minus x squared to replace the f of x. So 3 minus 4, this would be 3 minus 4. Yun yung i-approach niya value and that's negative 1. So this and this are equal. So the limit exists and is equal to negative 1. Okay? So again, we have a check there. And if we compare our answers, di ba? Dito sa number 1 tsaka sa number 2, these are equal. Yun yung condition number 3 natin. So check pa din tayo sa condition 3. So anong conclusion natin? All three conditions are satisfied. The function f of x is continuous at x equals negative 2. Okay. Now let's proceed to that other test point at x equals 2 naman. So let me erase our scratch work there. Unahin natin yung first condition, no? That is f of positive 2. So where is f of positive 2? It will be here. We'll be making use of this one. So it's positive 1. Let's use a different color naman, say the blue. Okay? So ito, f of 2 will be positive 1. Okay? Now for the limit, dito na tayo sa limit of f of x as x approaches 2. The limit from the left, you can verify that it will be equal to, using this function, the limit of this as x approaches 2 will be 3 minus 4. That will be negative 1. So let's write it here to make it more detailed. We'll replace the f of x by 3 minus x squared. So this will be 3 minus 4, which is negative 1. Whereas yung limit naman, as x approaches 2 from the right, we'll be replacing the f of x by 1. Ito yun, diba? Sa greater than 2 sides. So the limit is equal to positive 1. Negative 1 and positive 1 are not equal. So the limit does not exist. So failure tayo dun. So at x equals 2, what kind of discontinuity is this? We have a jump discontinuity. Okay, since the limits are not equal. The limits are not equal. Okay, let's move on to our next example. Okay. This time, meron tayong dalawa pa rin na critical points or transition points, si negative 1 tsaka si positive 3. Pero by inspection, ito continuous polynomial of degree 2. Quadratic din to, polynomial of degree 2. These are both continuous functions. Pero this time dito, meron tayong point of discontinuity na makukonsider, no? Because of this denominator. Bawal siyang mag-0. Okay? So si x here cannot be positive or negative 4. Okay? Kasi 16 minus 16 must not be 0, di ba? Yun, si negative 4 tsaka si positive 4. Si negative 4, fortunately, is not part of this interval. Pero si positive 4 is included in this interval. Okay? Kasi di ba if we are to make the real number line for this, ito si negative 1, ito si 3, andito si 4 eh. And for this side of x greater than 3, ito yung definition ng function natin. So it's x minus 4 over x squared minus 16 here. Sa middle part, yung x squared plus x plus 3. Sa first part, yung 2 plus x squared. So that's why aside from negative 1 and positive 3, positive 4 becomes a critical point or possible point of discontinuity. So we have negative 1, positive 3, and positive 4. Okay. Ayun. So, unahin muna natin si negative 1. At x equals negative 1, first condition, g of negative 1. So, san si g of negative 1, andito yung equality. Let's change our pen naman para colorful. Okay? Nandito yung yung equality, so we'll be making use of this. So negative 1 squared is 1, positive 1. 2 plus 1 will be equal to 3. So this is 3. Now for the limit, let's go to the limit as x approaches negative 1 from the left muna. Okay. So from the left, we'll be making use of this definition. So 2 plus 1, this will be equal to a 3. Yan, dapat meron pala ditong parentheses. So 3. Sa right naman, we'll be making use of this definition to replace our g of x. Ayun siya. Again, lagyan lang natin ng grouping symbol. Yan, that means the limit is being applied to the entire function. Okay. So we have 1 minus 1, magka-cancel out. So 3 na lang. So this will approach the value 3. So as you can see, these are equal. So equal limits means the limit as x approaches negative 1 exists and is equal to 3. So check tayo dun. And for the number 3 condition, equal pa din. No? So third condition is also satisfied. So all three conditions satisfied. So we have continuity at x equals negative 1. Okay. So the function g of x is continuous at that point. Yay. What about the next point? No? Next possible point of discontinuity is x equals 3. Unahin natin yung first condition, g of 3. San yun? Ito, dito yung equality. So we'll be making use of this function. So replacing our x by 3, we have 3 minus 4 over 3 squared minus 16. So that's negative 1 over negative 7. So that's positive 1 over 7. Check. Number 2 condition, as x approaches 3 from the left, we'll make use of this, no? To replace our g of x. Yan. Again, lagyan lang natin ng grouping symbol. This will be 9 plus 3. So plus 3, this will be 15. Okay. Pagka from the right naman, we'll replace the g of x by that expression. So ayun siya. So this is from the right. Okay. Pero di ba sabi natin if by substituting the number here at makuha na natin is a real number, yun na yung value. So replacing our x by 3 will get 1 over 7. Okay. So this and this are not equal. Therefore, the limit does not exist. And we have a jump discontinuity at x equals 3. Okay, yung isa na lang at x equals positive 4. Okay? So at x equals 4, kunin natin yung g of 4. So syempre 4 is in this interval or on this interval. So we'll be making use of this. 4 minus 4 over 4 squared minus 16, plain substitution po. That will be 0 over 0. Take note, we don't do factoring. We don't do cancellation pagka sa first condition. Okay? Sa second condition, so failure na siya dyan, kaya alam natin this is discontinuity already. Okay? Sa second condition, pero malay mo, removable, kaya pupuntahan pa rin natin yung condition 2. So we have limit as x approaches 4. Take note, we don't have limit from the left and right na kasi, di ba, sabi natin kanina, kung andito yung 3, andito yung 4, yan, for this interval, the definition of the function is x minus 4 over x squared minus 16. Ayan, so mapa-left, mapa-right side ni 4, ito pa rin function na to yung gagamitin mo to define your g of x. Okay? So ayun, kaya no need na po to split your limit on the left or right. No? So meron tayong ganito. This is 0 over 0, so magpa-factoring tayo. We expect x minus 4 to cancel out. So factors natin are this. Okay? Ayan, dapat meron pa rin tayong limit notation supposedly as x approaches 4. As x approaches 4, this fraction approaches 1. Magiging parang 0.001 over 0.001. Okay? So magiging approaching 1 lang sila. Okay? So we have 1 over 4 plus 4, which is 1/8. Okay. So 1/8 is a real number. So condition 2 is satisfied. Nag-i-exist yung limit niya eh, no? So, syempre hindi na tayo pupunta sa condition 3 kasi failure siya sa 1. Dahil na-meet niya yung condition 2, yun yung pinakamahirap na condition. That means, di ba pag condition 2, yung na-satisfy, mariremedyohan pa natin yung discontinuity. Parang pwede pang i-negotiate, no? Negotiable pa siya pag yung number 2 condition yung na-satisfy. So that means g of x has removable discontinuity at x equals 4. So the term that we have is removable discontinuity. Yan. Parang in the real sense, parang ano siya, negotiable. Pero dito sa ating terms dito, mathematical term natin is removable discontinuity. Okay? Bakit removable? So, ibig sabihin, mariremove natin siya. And we do that by redefining our function. I-redefine natin no, para the next time kunin natin yung at x equals 4, the next time kunin natin yung g of 4, okay na siya. No? Dapat ang makuha natin sagot, 1/8 para the limit is equal to the functional value. So we will be excluding 4 on this interval, diba? So lagay natin siya doon. Tapos ihiwalay natin na definition at x equals 4, we have 1/8. No? Special siya. No? So next time kunin natin yung g of 4, ang magiging answer na natin is 1/8. So pag kinuha natin yung limit, as x approaches 4, of the same function pa rin. Ito pa rin yung left and right ni 4, di ba? X minus 4 over x squared minus 16. Ang makukuha natin sagot dito eventually is 1/8. This will be equal, di ba? Condition 3 will be satisfied. Continuous na siya. Okay? Another way of doing this redefinition, aside from this, in-exclude natin, tapos nilagyan ng special treatment, nilagay yung limit value. This is the limit value, no? Another way of doing this is using the factored version. Remember, di ba, nung nag-cancel out si x minus 4, sino yung natira? Si 1 over x plus 4. And that applies kahit yung kay 3, no? 1 over 3 plus 4, that will still be 1 over 7. Okay? So ayun, hindi mo na siya kailangang i-exclude kasi this will still be 1/8, di ba? 4 plus 4 is 8. So 1/8 pa rin siya even at x equals 4. Okay. So parang tinanggal mo yung fraction na x minus 4 over x minus 4 kasi ito yung nagpapa 0 over 0. Yan yung 0 over 0 at x equals 4. Okay. Ayan po. So, let's see, no? Let's determine the interval of continuity. When we say interval of continuity, ang kailangan lang natin dito yung mga interval of x or the variable where the function is continuous. Okay? So, tatanggalin lang natin yung mga points of discontinuity natin. Okay? So, this is a rational function. Yan. So, kukunin natin yung mga zeros ng denominator. So, we factor the denominator. Okay? So, dito lang tayo mag-focus, no? Although, makikita natin si 6 will be a removable discontinuity at x equals 6. Magka-cancel kasi siya, no? Okay? Pero si negative 2, meron tayo dong masasabi natin infinite discontinuity later, no? Pero dito tayo magpo-focus kay denominator. Okay? So, we have the critical values negative 2 and positive 6. Yan, sila na lang yung ating magiging points of discontinuity. Kasi whether at x equals 6, kahit ba removable yung discontinuity natin dito, kung discontinuity pa rin siya. Okay? So, negative 2 and 6. So, it's like excluding the zeros of the denominator or yung mga hindi kasali sa domain ng function. Okay? Yung domain niya, di ba, excluded yung zeros of the denominator. So, si negative 2 tsaka si 6. Negative 2 is where? Dito, tsaka dito. Yun lang yung i-exclude natin. So, we'll be including this interval, this, and this interval. Okay? So, we have negative infinity to negative 2, which is this part. Ito yun. Negative 2 to positive 6. Ito yun. Okay? which is this part. Take note that we're making use of parentheses because we're excluding the endpoints. And then we have 6 to positive infinity. Okay. So, ayun po yung ating interval of continuity. Diba? Madali lang. It's a matter of just getting the domain of the function. This is actually the domain of the function. And in fact, fun fact, domain of rational expressions or rational functions, yan, will be the interval of continuity. Same as this one, no? Practice tayo. It's a matter of equating our denominator to 0. So, ang i-exclude lang natin, di ba? Make sure your factors are correct, no? Kasi magiging crucial yun, no? So, make sure you double check. Dapat negative 8, positive 3, negative 5, negative 8, positive 3, negative 24. You double check, okay? So, ang bawal sa atin, si positive 8 tsaka si negative 3. Okay. So, position natin siya dito, negative 3, si positive 8 is there. So we have the intervals negative infinity to negative 3, negative 3 to positive 8, and 8 to positive infinity. Okay? So kunwari tinanong sa exam, is the function continuous at this interval 9 to infinity? Yan. The answer is yes, kasi kasama siya dito. It's a part of this interval. Pero kunwari, so this is a check, pero if it's continuous kunwari at from 5 to infinity, yan. This is not correct kasi bakit? Yung 8 is part of this. So 8 is part of this interval which is a point of discontinuity. So you cannot graph the point on this interval ng tuloy-tuloy. Kasi 8 is part of that. Okay. So now let's determine the values of a and b so that f of x will be continuous for all real numbers. This is a different type of question naman that you may encounter for continuity. Okay, so for all real numbers daw, dapat maging continuous yung function. So ang nakikita natin na point of discontinuity are negative 1 and positive 2. Let's get a different color now. This time, let's use a dark yellow. So negative 1 and positive 2. Okay. So at x equals negative 1, let's see, we have here, ito yung ating equality, that will be 3 times 1 plus a. Remember, x yung nire-replace natin no, ng negative 1. So that will be negative 3 plus a. So yan po, no? We cannot check it right away kasi we don't have the value for a yet, no? Yun yung hahanapin natin. So for number 2, kunin natin yung limit from the left of negative 1. Ito yung gagamitin natin. So we'll replace our f of x by 3x plus a. Again, we need the parentheses here. This will be again negative 3 plus a. Yan. Kung galing naman tayo sa right ni negative 1, we'll be making use of this function. So that will be negative 1 times b. That will be negative b minus 1. No? Negative 1 times b is negative b minus 1. Okay, so for this limit or limit as x approaches negative 1 to exist, that means this 2 must be equal. So equate natin yung dalawang yan. Ayan. So we have the first equation. Ang first equation natin will be, i-polish lang natin to, no? We can smoothen this, no? Magiging lipat dito, tas combine the two constants. Okay? This will just be a plus b equals positive 2. Yan. So take note of this first equation. Ang task natin is to solve for a and b. Okay? So, set aside natin yan kasi we need this. Pagka once a plus b equals 2, yan, tapos magiging ano na po, mag-i-exist na yung limit natin as x approaches negative 1. Now we go to our next PPD or possible point of discontinuity. We have 2. F of 2 muna yung hanapin natin. So at f of 2, andito yung equality. So we'll be making use of this. That will be 2b minus 1. Ngayon, yung from the left naman ni 2, we'll be making use of the same function. That will be bx minus 1 pa rin. Okay. So, limit of that will be 2b minus 1 pa rin. Tapos sa right side naman, we'll be making use of this x plus 3. Okay. So, as x approaches 2, this will be 2 plus 3. So, that will approach the value 5. So, that means if these two have to be equal, that means 2b minus 1 should be equal to 5. 2b must be equal to 6 or b should be 3. So, meron ka ng value for b. Yan. Ang kailangan mo pa yung a, no? So, meron kang kaninang a plus b equals 2. So, gagamitin natin yan. No? Kanina nakuha natin b equals 3. So, we'll replace the b by 3. So, ang a natin is negative 1. So, ayun. A is negative 1. Nakuha na natin yung value na kailangan natin for the function to be continuous. At x equals negative 1, at x equals 2, and everywhere. Okay? Ay, sorry, b equals 3. Ayun. So, I hope you're ready for this time for questions. Kayang-kaya to, madali lang. Let's see, number 1, what are the possible points of discontinuity? Okay, fast forwarding our timer, the answer will be, ayan, it will be coming from these numbers that we see on the right side of our piecewise function. So they will be 6 and 12. Okay, next question. What are the possible points of discontinuity here? Okay, fast forwarding our timer, we have negative 1 and positive 1. So, meron tayo dito sa negative 1, tapos dito naman sa positive 1. Okay. Now, let's go to example 3, question number 3 rather. What are the possible point or points of discontinuity here? Okay, fast forwarding our timer, we have this value of x, and this value of x. So we have negative 4, positive 2, and positive 4. Okay, what about number 4? What is the kind of discontinuity at x equals 4? Okay, and the answer is removable discontinuity. Okay, the limit from the left tsaka from the right of 4 are equal. They are both equal to associated y here. Kasi leading tayo towards this whole, associated y is 2. So ito yung limit from the left and right of 4. Pero dun sa positive 2 natin, we have a jump discontinuity. Ganun din sa negative 4, we have a jump discontinuity. Okay, what about at number 5? What should be the value of k below such that f of x becomes a continuous function at x equals 2? Okay, you can just pause the video if you want to have more time answering. But let's answer this now. Yan, so kunin natin yung f of 2. For f of 2, condition number 1, we'll be making use of this definition kasi nandito yung equality. Replacing our x by 2, that will be 2 times 2, kaya 4k plus 5. Yan. Let's now change our color. Let's go to the maroon naman. Number 2 condition, kunin natin yung limit. As x approaches 2 from the left, tsaka limit as x approaches 2 from the right. So, 2 from the left, diretso na natin. No? Ito yung definition ng function. So, that will be 3kx squared minus x plus 1. So, as x approaches 2, this will be 4 times 3 is 12k. Minus 2 plus 1 is minus 1. Okay. Tapos from the right naman, ang f of x natin will be defined as 2kx plus 5. So this will be approaching 2. So 4k plus 5. Okay, so this have to be equal. So 12k minus 1 should be equal to 4k plus 5 for the limit to exist. Okay, nagkataon ito, nandito din yung 4k plus 5 kasi. So it's like solving a linear equation. So move the terms with variables on one side and the constants on the other side. So we have 5 plus 1. That will be 6. Tapos 12k minus 4k is 8k. Okay, so that means k is equal to 6/8 or 3/4. Ayan. So the next time you get the f of 2, this will be 3. Diba? Pagka 3/4 si k, that will be 3 plus 5, which is 8. Dito, double check natin. No? If k is 3/4, that will be 9 minus 1, so 8. Dito din, magiging 8 to. And therefore, sa third condition, okay na din siya. F of 2, which is 8, must be equal or will be equal to the limit as x approaches 2 of the function f of x. Yan, so all the three conditions will be satisfied. So I hope you got 5 out of 5 in this set of exercises. Yan, so to end our presentation, we have this motivational quote to inspire you. The only limits that exist are the ones in your own mind. Ayun, so regards to everyone. God bless you. Have a good day.